China has just pulled back the curtain on the 3Y Atlas discovery, and the details pouring out of its observatories have left scientists and governments with the chilling sense that the universe is far less empty and far less simple than many had hoped. For months, there had been whispers in specialist circles about an unusual object drifting through the solar system, flagged first as a routine data blip and then as a genuine interstellar visitor. Now, China has revealed the full dataset from its 3Y Atlas campaign. Those numbers appear to confirm what many astronomers and strategists feared in private, but hesitated to say aloud in public. This is not just another wandering rock from deep space. It behaves too deliberately, reflects light too cleanly, and responds to its environment in ways that seem to cross the boundary between natural and engineered. The story of 3Y Atlas begins quietly, as many profound discoveries do, with a faint streak on a sensor and a line of code flagging something that does not fit. Early orbital calculations suggested an object passing through the solar system on a hyperbolic trajectory, the hallmark of a body that came from outside our local planetary family. That alone would have been enough to spark intense interest since interstellar visitors are rare and precious. What made this one different was how quickly Chinese observatories pivoted toward it, as if they had been waiting for precisely this kind of visitor and had a plan ready to execute. China had invested for years in a coordinated network of optical, infrared, and radio instruments tuned specifically to track fast-moving, dim objects against the galactic background. The program, informally nicknamed the 3Y Atlas Initiative by its own engineers, was designed to give China an independent early warning and characterization system for interstellar intruders. When the new target entered the inner solar system, that network came alive. Telescopes across the mainland on high plateaus and aboard satellites aligned, changing exposure patterns and data pipelines in a matter of hours. What followed was the most concentrated observation campaign any single country had ever directed at a small transient object in space. The richness and complexity of the data, it's all there. The universe is, in a sense, hiding in the darkness, and we have to bring it out. The first hints that something was wrong with the natural object assumption came from the light curve. As the 3Y Atlas team stitched together measurements from multiple instruments, they noticed that the brightness of the object did not simply rise and fall with distance from the sun or with rotation, as standard models would predict. Instead, the reflected light showed sharp periodic modulations like the glint from flat panels sweeping through a beam. The pattern repeated with uncanny regularity, then shifted subtly over time, as if the object were adjusting in orientation rather than tumbling chaotically as most space debris does. In internal memos, Chinese analysts began to use cautious language about non-gravitational influences and attitude control-like behavior. Those words triggered deeper scrutiny. High-precision tracking showed that the trajectory of 3Y Atlas deviated slightly from the path predicted by gravity and solar radiation pressure alone. Similar anomalies had been debated for earlier interstellar objects, but the data then had been sparse and ambiguous. In this case, China had a dense chain of measurements taken with the benefit of advanced planning. The deviations were small but consistent, a gentle nudge in one direction that seemed to grow whenever the object approached certain distances from the Sun and Earth. Models that treated 3Y Atlas as a hollow shell, a highly reflective sail, or an outgassing comet all failed to match the observed pattern. The simplest fit was a model in which the object applied tiny intermittent thrusts comparable to the exhaust of a maneuvering engine. Inside the Chinese scientific establishment, this conclusion was not embraced lightly. Teams tried to break the data to find calibration errors, hidden biases, or unaccounted for forces. They cross-checked instruments and repeated measurements. Parallel groups ran independent orbital solutions using different assumptions. Yet every serious attempt kept circling back to the same uncomfortable point. The motion of 3Y Atlas looked guided. It did not scream with dramatic course changes or obvious propulsion plumes. It whispered with subtle corrections, the kind that would extend the life of a craft, minimize detection, and conserve fuel over vast distances. When China finally stepped forward to brief the world, the language remained careful, but the implications were unmistakable. Charts showed the light curve modulations, neatly aligned peaks and troughs that hinted at rotating flat surfaces. Plots of the trajectory overlaid with best-fit models exposed residuals that gravity could not explain. Spectroscopic data revealed that the surface reflected in a way that suggested composite materials rather than a random mix of ice and rock. The presenters avoided sensational labels, but anyone familiar with spacecraft engineering could see the analogy between those plots and the behavior of a controlled probe. The reaction beyond China was a mix of shock, skepticism, and a quiet, grim satisfaction from those who had long suspected that the cosmos is already active with intelligences older and more advanced than humanity. For decades, one fear had lurked behind the optimistic search for life: the fear that the first incontrovertible sign of a technological civilization would not come in the form of a friendly radio greeting, but as evidence that probes have been passing through our system for a long time without saying anything at all. The 3EY Atlas disclosure gave that fear a shape and a trajectory. It suggested that our solar system is not an untouched wilderness, but part of someone else's survey route, mapped and revisited as a matter of routine. The implications begin with the simple fact of intentional presence. If 3EY Atlas is a craft, then someone built it, launched it, and set it on a path that includes a close pass through our neighborhood. That means a civilization with technological capabilities at least comparable to our own and very likely far beyond. Any craft that can survive interstellar transit, navigate across light years, and perform microthrust maneuvers in another system is operating at the edge of our current imagination. The energy and engineering required are vast. The design decisions embodied in such a craft would tell us volumes about its makers, their priorities, and their comfort with crossing interstellar gulfs. One immediate implication is that our assumptions about anonymity in space are wrong. Humanity once imagined that until we built our own interstellar vessels, we would be essentially invisible to any neighbors. In reality, the development of radio, radar, and spaceflight left an expanding sphere of signatures around Earth. If others are actively surveying systems like ours, then they have likely logged those signatures, correlated them with changes in atmospheric chemistry and artificial lighting, and flagged our planet as a world in technological adolescence. The 3EY Atlas object, by its timing and path, appears disturbingly consistent with a civilization following up on such a flag, sending a sensor platform through a system where a new species is learning how to split the atom and launch rockets. Another implication lies in the geometry of the encounter. The path of 3EY Atlas, as reconstructed from the Chinese data, grazes the orbital plane of the inner planets and spends just enough time near Earth's orbit to collect high-resolution observations. Yet it avoids any direct collision courses or tightly bound orbits that would make its artificial nature obvious to casual sky watchers. This suggests a strategy of maximum information gained with minimum disturbance, the behavior of an observer who wants to see without being seen. It confirms the fear that if we are being watched, the watchers may prefer a one-way flow of information in which they learn everything they can about us while revealing as little as possible about themselves. The geopolitical implications are equally heavy. By being the first to assemble a compelling case that 3EY Atlas is engineered, China has positioned itself at the focal point of a story that reshapes humanity's place in the cosmos. That position brings prestige and leverage, but also risk. Other powers will want access to the raw data, independent verification, and most of all, any hint of additional information that China might be withholding. Trust between nations is already strained in many arenas, and the suspicion that one state might be sitting on knowledge about an alien probe adds an entirely new layer to strategic calculations. Sharing too much could dilute a unique advantage. Sharing too little could trigger paranoia and destabilizing accusations within China.